Hello class. In this lecture I will talk about hypothesis testing for two population proportions. So the concept in this is, if I have a population 1, suppose this is city 1, so and I am interested in knowing how many people in this city like color red. So the proportion of this will be represented by P1 of population 1. Similarly, I have population 2 and I'm interested, suppose this is city 2. Again, I'm interested in knowing how many of the people like color red. So if it is P2 and I wanted to compare these two cities, so three different instances can occur when we are comparing two different populations. One is the proportion of people in city 1 or population 1 should be equal to the proportion of people liking color red in city 2. So both are equal, so the number of people who like or the percentage proportion is percentage, also it can be percentage of people who like color red in city 1 is equal to the percentage of people who like color red in city 2. So that can happen. So this is a two-tail problem because this is exactly equal to. So if I wanted to disprove this, I have to look at both sides of a normal distribution curve. That means if P1 is less than P2 or P1 greater than P2, then I can disprove this hypothesis. So again, the formula for P1 is proportion would be x1 over n1, and this would be x2 over n2. Since these are populations, we will have capital N1 and capital N2. So the other situation that can happen is P1 less than or equal to P2. That means the proportion of people liking color red in city 1 is less than the proportion of people liking color red in city 2. So this is a one-tail problem because we are looking at one side of a normal distribution curve. So the third situation that can happen in this is P1 greater than or equal to P2, which is again the proportion of people liking color red in city 1 is greater than the proportion of people liking color red in city 2. So this is again a one-tail problem because we are looking at one side of a normal distribution curve. So in hypothesis testing, I have discussed previously, the first step of a hypothesis is to define your hypothesis, and these three events can happen. Define hypothesis. So the null hypothesis, the first thing that can happen is P1 is equal to P2. This can also be written as P1 minus P2 is equal to 0. So the alternative for this will be P1 not equal to P2. So this means P1 minus P2 is not equal to 0. So that is what can happen. Again, this is a two-tail problem. So another situation that can happen is H null P1 less than or equal to P2. So this is P1 minus P2 less than or equal to 0. alternative that can happen is P1 greater than P2. So this can be P1 minus P2 greater than 0. So this is one tail problem. So the next thing is H null P1 greater than or P2. This is another situation that can happen. So this means P1 minus P2 greater than or equal to 0, and then the alternative would be P1 less than P2, which is P1 minus P2 less than or equal to 0, not equal, less than 0. So this would be our hypothesis, and then as I discussed in hypothesis testing, the second step is to compare test statistic with critical value. So the test statistic in this case, again this is a proportion problem. We assume that the sample size is large enough in this, so we will be using a z-stat, and the formula for this would be before I discuss the formula for this, once we have these hypotheses, what do? We take the data, or we kind of sample from each population and look at what proportion of people like color red, because it's difficult uh, uh, get the number of people who like color red for the entire population. We take a sample. Suppose we take this sample and of size n1, small n1, then the mm, then the proportion of the sample is represented by p hat, and it will be given by x1 over n1. So this is proportion of sample. So x1 is number of people who like color red. In this case, and n is the sample size. Similarly here, n2 will be the number of sample size, and it is given by p hat is p2 hat is x2 divided by n2, and same the number of people who like color red and the sample size. So this p hat is very important, because now we will be using in our formula, and these p is also will be using in the formula. So if you see the formula would be for z stat z p hat p1 hat minus p2 hat p1 minus p2 divided by square root of p1 hat 1 minus p1 hat divided by n1 plus p2 hat 1 minus p2 hat divided by n2. So this will be our formula for test statistic. So there is another formula which your textbook will give. So mostly we will be using this formula in our calculations, but it is good to know this formula also. P1 hat minus P2 hat minus P1 minus P2 divided by square root of P bar 1 minus P bar 1 by n1 plus 1 by n2. So where P bar is x1 plus x2 divided by n1 plus n2. So because I discussed we will be using this, so this will be the formula. So the next thing is I will use critical value. So then you will have a critical value, you will compare it with critical value. So the critical value, as we discussed, for z, no, for two tail it would be z alpha over 2, because we are looking at both sides of a normal distribution curve. For one tail it will be z alpha, and then finally we will make conclusion of our hypothesis. So these will be the steps, and then I wanted to discuss here itself the confidence interval for comparison of two proportions, which is p1 minus p2. The formula would be p1 hat minus p2 hat minus plus z alpha over 2 multiplied by square root of p hat 1 minus p hat divided by n1 plus this is p1 hat. Let me check if I, yeah. So and then p2 hat 1 minus p2 hat divided by n2. So that will be our, again this will be the critical value in the formula. This is the standard error, and then this whole thing is called margin of error. So that's the concept for proportions. So I will try to do a problem on a proportion. So I will try to solve a problem. So here is our problem. So the US Census Bureau conducts annual surveys to obtain information on the percentage of the voting age population that is registered to vote. Suppose that 475 employed persons and 516 unemployed persons are independently and randomly selected, and that 210 of the employed persons and 195 of the unemployed persons have registered to vote. Can we conclude that the percentage of employed workers who have registered to vote is different from the percentage of unemployed workers who have registered to vote? Use a significance level of alpha is equal to 0.01 for the test. So the first thing in this is percentage of employed workers is represented by P1. So I will write that P1 is employed and P2 is unemployed. So the first step of hypothesis testing, this is a hypothesis testing problem because they are trying to ask us to prove the hypothesis. So the first step of a hypothesis is to define your hypothesis. So you have null hypothesis, you have alternative. So here can we conclude that the percentage of employers who register to vote is different? So when they say different, that means they are not equal. So proportion of employed is represented by P1 is different, that means they are not equal to P2. So this can also be written as P1 minus P2 not equal to 0. So the null hypothesis would be P1 minus P2 or P1 is equal to P2, this can be written as P1 minus P2 is equal to 0. So we have our hypothesis to support to see whether our null hypothesis is true or false. The data is given. So this is given data. So we have employed data and unemployed data. So the employed data we are given, suppose that 475 of employed persons and 516 of unemployed persons are independently and randomly selected. So that means N1 is 475 and N2 is 516, and then we have 210 of the employed are registered to vote and 195 of unemployed are registered to vote. So X1 is 210 and X2 is 195, and we are looking at significance level of 0.01. So the first thing in this you have to do, so if you see the second step, maybe I will just write the second step of hypothesis testing is to compare test statistic with critical value. So the test statistic formula, so we are using Z because it's a proportion. So the test statistic formula is Z is equal to P1 hat minus P2 hat, P1 minus P2 divided by square root of P1 hat 1 minus P1 hat divided by N1 plus P2 hat 1 minus P2 hat divided by N2. So the first thing we need to in this formula is what is P1 hat and what is P2 hat. So to get P1 hat, we will do here 210. The formula would be x1 over n1, which would be 210 over 475. So this is going to be 0.442. Again, P2 hat is x2 divided by n2, that would be 195 divided by 516. So P2 hat, we will get the value 0.378. So this is what we have to put here. So I will go into this formula and put those numbers. 0.442 minus 0.378 minus P1 minus P2. This comes from null hypothesis. So that is P1 minus P2 is equal to 0. So we put 0 here divided by square root of P1 hat 0.442 1 minus 0.442 divided by N1. N1 is 475, and then plus 0.378 1 minus 0.378 divided by N2 is 516. So that is what we are going to do. So if you calculate this, the numerator Z is equal to 0.64198 and the denominator will be 0.0 3 1 2 2 3. So this is going to give us 2.056. So that is our z value. So the next step is to compare it with critical value. So this is a two-tailed problem because our null hypothesis is exactly equal. So if we wanted to disprove if P1 is less than P2 or P1 greater than P2, we can disprove the null hypothesis. So that means we will be using for critical value Z alpha over 2 formula. So our alpha is given as 0.01. So I will go and write alpha is 0.01. So alpha over 2 is 0.01 over 2, that is 0.005. So we are looking for z value of 0.005. So if I show you this in a normal distribution curve, so if this is a normal distribution curve and it is a two-tailed problem, so this will be like this. So 0.005, so this region will be alpha over 2, which is 0.005, and then this region would also be alpha over 2, which is 0.005, and then this region would be 99%, 0.99. So if you consider this one is P1, this point is P1 minus P2 is equal to 0, and this curve represents null hypothesis. So anything in this area, because we wanted 99% confidence when we say alpha is equal to 0.01, this will be a do not reject null hypothesis. So when I say do not reject null hypothesis, that means P1 is equal to P2 at this point. So in this region P1 will be equal to P2. So if you see this region, oh sorry, I will use it. So if you see this region, because it's a positive side of this number line, P1 will be greater than P2. That means in other way, alternative P1 not equal to P2 will be true in this region. And then in this P1 is less than P2 because this is a negative side of a number line. So P1 not equal to P2 will be true. So here in this region I will reject H null, and again in this I will reject H null. So now I wanted the z value at probability 0.005. This is probability. So I will go to my canvas page and look for z value at 0.005. So again I'm going to modules. I will go to calculation aids and then download statistical tables. And then do enable editing. Currently I am in Poisson table. I will go to Z table and I am going to look for Z probability of 0.005. So that is what I am looking for. So this 0.005 is what I'm looking for. So I will go and look for 0.005 in this table. So let me go and look for 0.005. So 0.005 will be somewhere here or here. So the z value would be negative 2.57 or 58. So I will take negative 2.58. So again, z is giving you left side of the normal distribution curve. So it's going to give me this point, negative 2.58. So this will be obviously positive 2.58. So now I'm going to go and look at where does my, once I have critical values, where does my z value lie in this number line. So I'm looking at where is this 2.056. So this is 2.5. So 2.056 would be somewhere here. So that means it's in the do not reject H null hypothesis. So this is, I'm saying don't reject this, that means this is true. So that means P1 is equal to P2. So as the question asks, can we conclude that the percentage of employed workers who have registered is different from, no, that is not. So there is not sufficient evidence to conclude that the percentage of people who are employed is different from the percentage of people who are unemployed. So in this case P1 is equal to P2. So both unemployed, employed and unemployed have same percentage. So we can again test this hypothesis using confidence interval. So I will write confidence interval formula and try to solve it, and then we will try to solve with calculation aids. So confidence interval for comparison of proportions, which is written by P1 minus P2. So the formula is P1 hat minus P2 hat minus plus z alpha over 2 square root of P1 hat 1 minus P1 hat divided by n1 plus P2 hat 1 minus P2 hat divided by n2. So again P1 hat, P2, all the information you have obtained. So P1 hat is 0.442. So this would be 0.442 minus this is 0.378. So this will be 0.378 minus plus z alpha over 2. I'm sorry, z alpha over 2. If you see this, z alpha over 2 you got here, that is negative 2.58. You went and looked at z table. So that would be negative, or negative positive is taken care of this sign, 2.58 multiplied by square root of 0.442, 1 minus 0.442 divided by n1 is 475. So you will type in, you'll write 475 plus this will be 0.378, 1 minus 0.378 divided by, this is N2 is 516. So 516. So if I calculate this, the first portion, this one would be 0.064189 minus plus 2.58, and this calculation would be 0.031223. So if I calculate 0.064198 minus 2.58 multiplied by 0.031223, so this is lower limit. So this is going to give me negative 0.01636, and then upper limit is 0.64198 plus 2.58 multiplied by 0.0312223, and this is going to give you 0.141444753. So our limits are negative 0.01636 and positive 1444753. So if you see in this the lower limit is negative number and the upper limit is a positive number, so that means 0 is in between them. So that's the reason we can conclude that P1 minus P2 is equal to 0 is true. That means P1 is equal to P2. That means both the proportions are true. So this is how we will be solving those problems, but I will now use calculation aids to solve this problem. So I will note down all these numbers, so rather than so our hypothesis is H null is P1 is equal to P2. H null is P1 is equal to P2, or P1 minus P2 is equal to 0. Alternative is P1 not equal to P2, that is P1 minus P2 not equal to 0. And then what all data is I'm sorry for this, what all data is given, let's see. So the given data is employed and we have unemployed. So again I'm copying the data, whatever we did here. So N1, I will copy this, I will copy this, and then I will copy alpha is equal to. So I have this in a sheet of paper, so I will just copy those numbers. So N1 is given as 475, X1 is 210, and then N2 is 516, X2 is 195, alpha is given as 0.01. So this is the given data, so I will go and key in these values into the calculation aids. So I will go here. So the difference between chapter 10 and chapter 11 is chapter 10 is one sample and chapter 11 is two samples. So you have to understand the difference. So I will go and download chapter 11 calculation aids and now do enable editing. Now this is a proportion problem. So I will go to proportions, and in this gray area I will be entering the values. So this is sample 1. So our sample 1 the mean they are asking, I think x1 they are asking, not the mean. X1 is 210. Let's see. Yeah, number of events x for this is 210, and then enter, and then sample size, that is n1. So the sample size n1 is 475. So this is 475. So again n2. So I will look at it. Okay, so this is x2 they are asking, not n2. X2 is 195. So x2 is 195, and then this is, I think this should be 510. Let me cross check. Or 516. Yeah, this is 516. 516. And then alpha value is 0.01. So I will type in alpha 0.01. So if you see, this is the critical value for confidence interval, this is standard error, and then this is lower bound and upper bound, negative 0.0162 and positive 1.144. And then because our hypothesis, if you see, we have a hypothesis of P1 minus P2 not equal to, so I will go to our sheet and then I will look at P1 minus P2 not equal to, so I will be using this case. So my critical value is 2.57. I don't reject H null, so that means P1 is equal to P2 if I don't reject the H null. So that's how you'll be solving these problems. This concludes my lecture on proportion. Thank you.